Hey guys, I want to go over how to solve rational equations. That's chapter 6.5. Really all that rational equations is equations with rational expressions in them, and usually they have variables in the denominator. So remember that if I had something like 3 over x equal to 2 over x minus 1, this is a perfect example of a rational equation. But remember that the denominators of either of these fractions, they can't be zero. So when you're solving rational equations, you should factor all the denominators. And then you should also say any restricted values, like the values that x can't be as I go along and solve this. In this case, the restricted values are x can't be equal to 0, because if x is 0, then the whole denominator on the left is 0. 3 divided by 0, that's undefined. I can't have a 0 underneath. But also, x can equal 1, because if x was 1, 1 minus 1 gives me 0, so that 2 divided by 0 is undefined. So really I'm saying x minus 1 can't be equal to 0, so that x can't be equal to 1. That's where I'm getting that restricted value from. But these are the restricted values. These are the numbers that I can't get when I get my answers. I haven't actually talked about how to solve this equation here. I'm just saying that these are the values of the variable that I can't get outright. All right, I can't get x equals 0 or x equals 1. The question is then, how do I actually solve it? Well, the trick is, or the key is going to be fraction busting. So you should always multiply by the least common multiple of the denominators. In this case, you should multiply by x and x minus 1 to both sides. You're multiplying by that over 1, so that the x's cancel, the x minus 1's cancel. You end up with just a nice equation without fractions. So that you'll be able to solve, and then you should also check for the extraneous solutions. If at the end you end up with 0 or 1, you got to throw those out. They're no good. So let me actually take this problem, since I just wrote it up for a second, and show you what I mean. Say I wanted you to solve 3 over x equal to 2 over x minus 1. We already said that x can't be 0 or 1 when I do all of my work I'm about to do. But what I'm telling you is you should first ask yourself what the least common multiple of these two denominators is. The least common multiple between x and x minus 1 is x times x minus 1. That's the least common denominator. Notice I want to multiply by x over 1 so that the x's cancel, but then I also have to do it over here, and I can't cancel the x's because of the addition. So the truth is I shouldn't just multiply by x. I should multiply by more than x. I should multiply both sides by x and x minus 1, each of the two factors. If the denominator is not factored yet, you have to factor it. But the point is that on the left, the x's will cancel and leave me with the 3 times the x minus 1, and then on the right, the x minus 1's will cancel and leave me with the 2x's. So that I get 3x minus 3 equals 2x. That's an equation I could solve. If I subtract the 2x over, I get x minus 3 equals 0, right? Subtracting 2x from both sides, and then I add the 3 over, I get x equals 3. This is not one of my two restricted values that I couldn't get, so x equals 3 is totally fine as a solution. If I plug it back in, I get 3 over 3 equals 1. 3 minus 1 gives me 2, and 2 over 2 is also 1, so it works. I could check it by plugging it back in. But the check that I'm talking about is make sure that your solutions weren't any of these extraneous or any of these restricted values. If they are, you have to throw them out and then come up with or you get no solution, depending on how many of them there are. So let's say that there's a bit more. Let's say that now I want to solve something like the problem of the day, where I want to solve x plus 3 over x plus 1 equal to 2 over x plus 1. The problems of the day will have the same denominator. It's because I don't want you to have to worry about finding the LCM, again, even though I know you can. Today in class we'll do a bunch of the harder problems, but for now I just want you to understand that all I'm doing is saying right away x can be equal to negative 1, because if x was negative 1, the denominator in both cases would be 0. So whatever work I do here, I better not get -1, otherwise I have to throw it away. It's a restricted value. So let me rewrite the problem so that I have enough space to actually fraction bust. In this case, there's only one denominator. It's x plus 1. So when I multiply both sides by x plus 1, the denominators cancel. And then I just get x plus 3 equals 2. Well, then when I subtract 3, I get x equals -1. But this was a restricted value. So if I'm getting a restricted value, I have to cross this out. This is technically an extraneous solution. It's a solution that wasn't supposed to be there. We call it extraneous because it was one of the solutions that makes this whole thing undefined. So the truth is, my one solution that works wasn't supposed to be allowed to be there. There's actually no solution to this problem. Every once in a while, you end up with a type where maybe there's multiple solutions and one of them's extraneous, so you just throw out one of them. But in this case, that's not true. And actually, I included 2 problems of the day. There's another problem of the day that has different factors on bottom. So this is really what you should be going for trying to solve rational equations. Say I want to solve something like x squared minus 9 over 3x squared minus 8x minus 5 plus -4 over x minus 1 equal to 2 over 3x minus 5. Well, first I want to know what the restricted values are. The restricted values come from the denominators. Well, before I can find those restricted values, I have to factor all the denominators, meaning I should rewrite this denominator on the left in factored form. We've talked a lot about factoring, so I'm not going to show you how to factor this. I'm just going to tell you that it factors to be 3x minus 5 and x minus 1. There are videos on factoring. You should factor by grouping using the AC method. But then these two are already factored, x minus 1 and 3x minus 5. Nothing happens there. So I'll put them in parentheses to say I already tried to factor them. Now I see that the restricted values are whenever x minus 1 is 0 or whenever 3x minus 5 is 0. Those are the only factors, right? So these x minus 1 shows up here and here, but there's no need to do the problem twice because if I'm solving it here, then I'm also solving it here. If I'm solving 3x minus 5 can equal 0, that means that 3x minus 5 also can equal 0 here. There's only 2 unique factors on bottom, so I'm only going to get 2 restricted values. X equals 1, and if I add the 5 over on the right, I get 3x equals positive 5. Divide both sides by 3, you get that the other restricted value is 5/3. So there are 2 restricted values. I'm going to copy this and drag it to the other page to start the problem over again. There it is. Oh, there it is. So here's the problem, and let me rewrite the fact that the restricted values now, I know that x can equal 1 and x can equal 5/3. So when I solve this, I better not get one of those 2 answers, otherwise I got to throw it away. But I got to fraction bust this, so I got to multiply top and bottom by the same thing. I have to multiply by whatever the least common multiple of the denominators is. So I'm going to take x squared minus 9 over 3x minus 5 times x minus 1 and multiply that not just by x minus 1, that will cancel only one of the factors, but also by 3x minus 5. I'm also going to do that to the -4 over x minus 1. I have to multiply it by the same thing, x minus 1 times 3x minus 5. And then 2 over 3x minus 5. I multiply top and bottom, or I multiply the top by x minus 1, 3x minus 5 also. Sorry, I'm running out of space. The point is, this 3x minus 5, it's going to cancel out anyway. So if I multiply the numerator on the right by 3x minus 5, also it cancels out. Let me just do this one first so that I can scroll back over. The x minus 1 stays. Just the 3x minus 5s cancel out. But I should go through and cancel everything else out too. Like on the second term, the x minus 1s cancel, and everything cancels on the left. The x minus 1 and the 3x minus 5. I'm fraction busting here. So if I do all this work and there's still fractions, I did something wrong. The first term has no fractions now. It's x squared minus 9. Then I'm going to rewrite the negative 4 with the 3x minus 5 because that's all that was left. The x minus 1's canceled out. And then equal to 2 times x minus 1. So this is some pretty intense fraction busting, but it's still just fraction busting. The point is that now that we've gotten rid of the values, or now that we've gotten rid of the fractions, I have an equation that I can solve. X squared minus 9 minus 12x plus 20 should equal 2x minus 2. Or if I move everything to one side, I get x squared. Let me just simplify first. Minus 12x. Negative 9 plus 20 is positive 11 equals 2x minus 2. When you subtract 2x and you add the 2 over, you get x squared minus 14x plus 13 equals 0. Sorry, I'm running out of space here, so I got to be a little careful. But also, what happens is this is a quadratic equation. That's why I'm moving everything to one side. Like a lot of people usually get stuck at this step right here. If you're getting stuck here, you should ask yourself, what am I trying to do? I'm trying to solve this equation. But in this case, I now have a degree 2 equation. I have a quadratic equation. So I want to simplify, get everything on one side equal to 0 so that I could factor. X squared minus 14x plus 13 does factor. It factors to be x minus 13, x minus 1, so that I get two answers. X minus 13 equals 0 when x equals 13. X minus 1 equals 0 when x equals 1. That's a lot of work. I'm surprised I squeezed it all in here. I'm sorry for the mess. I had to squeeze it all on one page. The point is I got two answers, but I have to go back and check, are either of them extraneous? Remember, 1 was a restricted value and 5/3 is a restricted value. So x equals 13, that's okay. X equals 1, that's not okay. This is an extraneous solution. It's an extra solution that shouldn't be there. Really, we should call it extraneous. Alright, so let me show you one more problem. Again, a similar one to that last one, since that was pretty difficult. Say I wanted you to solve x squared plus 24 over 3x squared minus 7x minus 6 plus negative 3 over x minus 3 equal to negative 1 over 3x plus 2. Alright, so looking at this, I see that it is a rational equation. I want to talk about the restricted values, but I can't until all the denominators are factored. So that's why the first step was factor all the denominators. Well, x squared plus 24, that's in the numerator, but the denominator down here factors to be 3x plus 2 times x minus 3. The second factor, the second expression, that doesn't factor, so I'll just leave it as x minus 3. And then same thing, 3x plus 2, that doesn't factor, it just stays 3x plus 2. Now I see that the restricted values come from x minus 3 not being able to equal 0 and 3x plus 2 not being equal to 0. I see that these factors match and these factors match, so there's no need to really do all four expressions. I can just do an x minus 3 and a 3x plus 2 and say those two can't be equal to 0. In that case, then I get x equals 3 and 3x equals negative 2. So then if I divide both sides by 3, I get x equals negative 2 over 3. The point is these are restricted values. X can equal 3 or x can equal negative 2/3. So I'll try to squeeze all the work on the next page again, just like we did a second ago. You see, I haven't done anything. If I'm asked to solve this, really, I haven't done anything. At this point, I just know what the restricted values are. I know what my answers can't be. maybe I'll actually go back because I think I copied the wrong one. It would have been much better to copy the factored version. So let me, add this one back to this page. Sorry, let me try to squeeze it in here. Boom. All right, there it is. Again, I haven't actually solved anything. I just found that x can't be equal to 3 or x can't be equal to negative 2/3. These are the two restricted values that I got from setting the denominators equal to 0. But I want a fraction bus. I want to multiply everything times 3x plus 2, x minus 3. Really, I'm just doing it on top so that I can cancel out the denominators. When I do it to the first term, I'm left with x squared plus 24. That's it. There's no more fraction. But because I multiplied by these 2 to the first term, I also have to do it here. 3x plus 2 and x minus 3. That gives me negative 9x. Because the negative 3 gets multiplied times the 3x and times the 2, so I get negative 9x minus 6. And then I also have to multiply this top by 3x plus 2, x minus 3, so that I'm left with negative x plus 3. The negative multiplies times the x and times the negative 3 to give me negative x plus 3. Again, sorry, I'm trying to squeeze all of this work into one little page, so it's a little bit messy. But for now, let me just simplify. X squared minus 9x plus 18 should equal negative x plus 3. This is usually where I see people get stuck. They say, oh yeah, this looks much better because I fraction busted it. I don't have to deal with some messy equation like I had on the previous page. This equation here is kind of scary because of the fractions, but I'd much rather deal with the one that doesn't have any fractions. But they get stuck here. They're like, now I'm actually kind of stuck. I don't know what to do. The point is, this is a degree 2 equation. It's a quadratic equation. We want it in standard form. We always want them equal to 0. So I should add the x over so that x squared minus 8x plus 18 equals 3, and then subtract the 3 over so that x squared minus 8x plus 15 equals 0. The truth is that these problems are already long enough, so we'll probably give you something that's always factorable. Think about it. Which two numbers multiply to 15 and add to negative 8? Negative 3 and negative 5 multiply to 15 and add to negative 8. I can use the shortcut because a equals 1 here. So the zero product property says I have to take x minus 3 and set that equal to 0. I get x equals 3. And then I have to take x minus 5, set that equal to 0. I get x equals 5. Well, if I got these two solutions, that's great, but the truth is one of them was a restricted value, so I can't include that one. It's extraneous. But x equals 5, that one's a totally fine solution. So if I wanted to, I could go back to the original and check by plugging it back in. All right, so I know it's a difficult chapter. It's a good idea to practice it before you see it in class. We'll go a lot slower in class, and I think you'll see that watching the video definitely helps in advance. So let me know if you have questions before we start. That would be great. Otherwise, we'll just jump straight into it in class. All right, I'll see you guys.